Okay, how are you doing? How are all of your viewers doing over there at home? Now I really hope that you enjoyed the part about vectors thus far. But I must say now things are gonna get a little bit more difficult. Okay, this chapter is we're gonna talk about vector fields, and it's the start of a whole range of topics which the difficult level notches up quite a bit. Okay, why do I say by that? Okay, remember the introduction how I said that vector calculus is not multivariable calculus? Yes, that is true until now. Sorry to say that because now we're gonna introduce multiple variables. Okay, previously, if you have been coming to Gaussian technologies, we had this x squared I plus 3xj, for example. This is a vector function with a single variable, in this case it's x. Now we're gonna move a step further by defining a vector function, g, in this case, x comma y equals to a function 1 in xy I plus a function 2 in xy. And these, we say again, are the component functions, and this is the vector function. So let's take a minute to see what this means. Okay, or maybe we see what this means, because I hope that we should really get clear on these terms, especially if you are not too familiar with vectors yet. It's absolutely vital that we get these terms clear as the difference of these two equations. This equation means you think of a value of x, any value along the x plane over here. Okay, think of the value, put it inside here, you put that value into the corresponding component functions, and then you get the vector that is in terms of I and in terms of j, the component vectors. Okay, the component vectors, this one and this one. But you only think of a value, one value of x. Now we come over here. Now what does this say? This says that you think of a value of x, and then you think of a value of y. Think of those two values, use those two values, put them inside g1 and g2, depending on what the functions are, and then you get the vector of I and j. So this introduces the concept of finding vectors in a plane such as, think of a value of x, think of a value of y, this point over here, and then what is the corresponding vector. Okay, previously, for this one is think of a value of x, for example, over here, corresponding vector. This one, think of a value of x, think of a value of y, and we get the corresponding vector. Now, that kind of makes things a bit more difficult, but I hope to clarify that with a practical example. Let's just say that the vector function like this, xy I plus x take away y j. Okay? And then we are given these points, g, 1 and 1. Okay, which I already calculated out to be I. Okay, g, 1 and 4, which is 4i plus, 4i take away 3j. And g minus 1, 0, which is minus j. Okay, so we got these 3 points here. So I will think of the points matching up with the coordinates over here, 1 and 1, and then my vector over there would be I, which is here. Okay, that's why now we are bending the rules a bit, because the x and y plane are already, it becomes the I and j plane, if you kind of know what I mean. Okay, let's just think about it as I and j dictates direction, x and y dictates position. Okay, got a value of 1, 4 over here, and it gives us 4 and then minus 3, so it'll be something like that. And a value of minus 1 and 0, it gives us minus j, so it'll be like that. Okay, so think of the points and then get the corresponding vectors. That is all nicely done.